Example 2, in sketching cosine functions, we have function fx equals to 1 minus cos 2x. So to sketch this graph here, we will begin with the first thing, the phase shift, where we take the bracket terms here equals 0. So we have 2x equals 0. And from there, we solve the x, we find out x equal to 0. And the cycle of the graph later will begin with x equals to 0. Then next, we find the periods, where we have 2 pi over modulus of m, where the m is corresponding to the coefficient of x in the brackets here. So in this case here, we have the answer equals to pi, where one cycle of the graph later will complete in the length of pi. And next, using this period, we find out what is the sub-interval width, where we have period divided by 4. And in this case here, pi over 4 is the sub-interval width, which is also the common difference of the x value later when the time we construct the table. So next, table. In here, we will have a table for one cycle, where we start with the first column with x, second column with fx, corresponding to the x and fx inside the functions here. Where for the x value, we begin with the x value. We will start with the phase shift value that we find out, which is x equals 0. Follow the next value. We will add on this value here with the common difference we find from the sub-interval width, pi over 4. So we plus pi over 4, plus pi over 4, plus pi over 4, plus pi over 4. Then next, we will proceed to find the function value accordingly, where substitute all this x value here into the function of fx. So these are the corresponding value that we have, 0, 1, 2, 1, 0. And as a result now, the table for one cycle graph is already ready, and we next can go for the graph sketching. So by referring to the table, I will begin with again the x-axis by plotting all these points here from 0 until pi accordingly into the x-axis. Then we insert the y-axis with the corresponding reference value that we need according to the table. We need to have the reference value of 0, 1, 2. So therefore, this is the y-axis that I need to prepare. And now, we will proceed with plotting the one cycle graph, where we have the first pair of value, 0, 0. Second pair, pi over 4, 1. Then the third one, pi over 2, 2. 3 pi over 4, 1. Pi and 0. So this is the plotting that we have. By the time we connect this plotting here according to the shape of cosine functions, so this is what we have for the graph. And of course, once again, let us erase the trace of the plotting. So this is the graph for these examples here for the case of one cycle. And after I have this one cycle graph here, I'm going to use this as foundation to extend into other domain that is required by the questions. So if let's say I have the case that they ask us to find the domain for all real number, and if let's say this is the size of the coordinate axis that I have sketched initially, so the coverage will be the full coordinate axis. And in here, let us further extend the x value to the left and to the right according to the size of the coordinate axis that I have. So the next value after pi, I will have it with the additional of pi over 4, as what we find out in our common difference just now, which is also the sub-interval width. Then to the right, to the left, we will have it minus pi over 4 accordingly. And this is the result that we have. And now what we do is that we're going to extend our graph towards the right and towards the left with this shape here. So therefore, this is what we have for the answer for example number 2 for the case of cosine graph, where we have the domain is all real number. And what if, let's say now I consider another case where I would like to have the domain as 0 until 2 pi, which is equivalent to 0 until 360 degrees. So again, I use the one cycle graph here as a foundations. And next, what I'm going to do is that I would like to find out where is the locations of 2 pi from here. So I find out that the largest x value I have for the one cycle is until pi. So I need to extend further until 2 pi. And when the time I extend, I will have from pi, continue adding pi over 4, which is the common difference we find out just now. So we extend plus pi over 4, plus pi over 4, so on and so forth, until I can reach 2 pi. And in this case here, just nice, we reach 2 pi. And this is the coverage that I should have for the graph. And next, what we're going to do is, we're going to have this one cycle here, continue to extend accordingly, and have the graph look something like this. So this is how we sketch for the case for from 0 to 2 pi as the domain.